Hello everyone. In this session we'll discuss a question on increasing and decreasing function. So the question says find the interval for which the function is increasing. Function is f of x is equal to x to the power 4 into e to the power of minus x. So we have to check the range or interval for which the function is going to be increasing. First of all, we know if the function is having the first derivative greater than 0, then it is increasing, and if it is, or you can say monotonically increasing, if it is greater than equal to 0 or less than equal to 0, then it is monotonically decreasing. So first of all, we should find the derivative of this function. Derivative of this function can be written as, let's say this is u and this is v, then u dash into v plus u into v dash. So this is going to be x to the power 4 will give you 4x cube into e to the power minus x, and this will give you minus x to the power of 4 e to the power of minus x, right? This becomes this value. Of course, we know that e to the power minus x is non-negative value, right? This e to the power minus x is going to be non-negative, and it will be 0 when e to the power minus x will be 0 at infinity, right? So let's not take this part now. Of course, this is valid here, but let's talk about this, because this is going to be 0 at infinity and it is going to be non-negative, so it will not have much effect on the nature of the derivative here. So let's talk about x cube into 4 minus x. Let's say we have two parts here, into x cube into 4 e to the 4 minus x. So possibly we can check this, and we'll see that the function is going to have roots at x equal to 0 and x is equal to 4. So we can have possible roots at 0 and 4, because we'll need to know this where this function is going to be 0, and from stationary points only we can check on the left or right it is going to be increasing or decreasing. So let's say for a value x less than 0, in case of x less than 0, this will be negative and this is going to be positive. So ultimately the product of negative and positive will give you negative. For x in the interval of 0 and 4, this term is going to be positive and multiplied with another term 4 minus x. So 4 minus x will be also positive. So this overall function value is going to be positive. And for x greater than 4, this x cube will be positive, but this 4 minus x will become negative. So this function will become negative. Other than that, at x equal to 0 and at x equal to 4, this function is going to be 0. The derivative is going to be 0. So we'll check on the left and right of the stationary points only. There only we can check the whether it is going to be increasing or decreasing. So that means now that we want the function to be increasing, we have this derivative to be positive in the range of 0 to 4, which means this f of x will be increasing in the interval 0 to 4. Of course, you can include 0 and 4. It is a continuous function, so it won't matter much, right? Another way we can use it, we can find the derivative values, right? Like we can see the roots for this equation, that is f dash of x is 0 and 4. And of course we said that e to the power minus x is not having much effect here because it is going to be non-negative, and the function value e to the power minus x will be 0 at infinity. So we are talking in the finite region, right? In finite region it is not going to change the sign, and it is not affecting the magnitude also much, like in the sense of nature. So our concern is that the roots are 0 and 4 for the f dash of x. Then we can check any random value for less than x. Let's say we are checking it for f dash of minus 0.5, and then we can also check for any value, let's say anything between 0 and 4, let's say it is 1, and any value for greater than 1, let's say it is 5. Or if you want to make it easier, let's take it 0. The point is, when we have this finite number of roots 0 and 4, we cannot have this change of the sign of this derivative everywhere. We'll have it either before 0, then after 0, before 4, or after 4, right? In that sense, we can see that for f dash of minus 0.5 it is negative, it is positive, and it is negative. I'm not talking about the exact value, you can find it. Then we can obviously see that the sign changes from minus to positive at this 0, and then positive to negative at this point 4. So between this, or in the interval of 0 to 4, this is overall positive. So if you are not approaching in this manner, you can approach in this manner. That will also help you if you have a better understanding of the roots of a function.